Амар, ты меня слышишь?
Да, я слышу.
Ну все, мы продолжаем, потому что у нас один представитель не пришел, и мы решили, чтобы не каждый реферат был в то время, которое описано в программе.
Да, понятно.
Поэтому мы начинаем. Я представляю. Ну, я придумал.
Я вообще в вашей секции или в другой секции?
Нет, в нашей секции. Секция прикладная математика. Ну, посмотри по программе. У тебя же есть программа в онлайне. На сайте Семеил Семен.
Я это распечатал.
Есть секция.
Если я главное, что будет, когда будет моя практика.
Хорошо, хорошо. Окей. Dear friends, we continue our work. Спасибо. I present Mrs. Tkachenko Alexandra, Associate Professor of the State University of Moldova, Department of Mathematics. She presents your reference in this. Okay. Thank you.
First of all, I have the pleasure of welcoming you to this important conference and wish for you to have a beautiful work and to present beautiful work. God help you. Thank you. Topic of my paper is the efficient method for solving the linear multi-criteria optimization model in integer. I speak about this topic initially. Why multi-criteria? Because the multi-criteria model is one of the more demand in actually currently. Because the decision maker wants to obtain one solution, real solution, which can improve more of the criteria at the first. Evidently and obviously, in this case, the solution algorithms are more complicated, but for which decision situation, the algorithm may be unique, like of Doppler. Why in integer? Because again, actually, more of the problem need to found it the solution of integer type. Number of quantity, number of machine or another kind of variable. Again, this type of problem complete more the model. This is why in this paper I developed two efficient algorithms for solving the multi-criteria models with linear objective function in integer. Because if I search actually the model of non-deterministic but fuzzy data, again, is actual but it's more complicated. But if I search the model with non-linear criteria, it's interesting but it's more complicated. All right, topic is this, and I present this work to in first chapter is a little introduction. Introduction develops the historical of model in integer and some researchers which proposed some algorithms, including me, obviously Problem formulation is the next. The model one, and how you can observe in this criteria, min-max, meaning what between the objective function you have of minimizing type and right of maximizing type. I can to observe that is not necessary to improve the model and to found it of the same type. Is not necessary, and I can to speak about the inequation x less of b is in the same restriction of linear programming problem, what is the available area of solution. But is complete this model, x is from the set z plus. Evidently, if increasing number of criteria, the algorithm became more complicated. Some statement about the multi-criteria problem. More of a point of view about solving this model led to some definition of solution for this model. Obviously, is not possible to found it one optimal solution for multi-criteria model because some criteria can be contradictory between them. In this you found it the notion of Pareto optimal solution or solution with the best compromise or the efficient solution. To solve the kind of model are more of point of view. First is to find it one objective function as dependent over each criterion, and this function is one function synthesis function which includes all of these criteria. And solution can be interpreted with the solution which realizes all criteria. But the problem is how you construct, how you build the function. Some models, some methods proposed for some authors in proposed references. Another point of view is to found this one solution what minimize the distance from this and the optimal solution of each criteria is very good point of view. Yes, and the third is point another kind of regarding is to found one set, on closing set, infinite set of solution. Again, this is basic solution. This is why it's finite set of solution from that Z plus in this area, namely efficient solution. This is why I propose the definition about the notion of efficient solution. in Z plus. The solution X with is of model 1. Model 1 is proposed already from this area is called the optimal for all model is if it is optimal for each criteria. And how I outline, this case is impossible. It's possible when a number of criteria is not true, because the optimal solution for the next criterion is founded on the set of optimal solution of previous criteria, and not often this is possible, because each objective function Serral have one solution, rarely two solutions, yes? And the second solution not obviously to be optimal for the second criteria. Another definition too, the basic solution from this for model is basic efficient if doesn't exist another solution from this area, different of first, which would improve the value of all criteria, and at least of one criterion is strictly improvement. Because when I speak improve, may be equal, but improve was one criterion. This is efficient solution, and I accept on this kind of set and propose to found it the set of all efficient solutions. But all efficient solution is practically impossible because I know, you know, that the statement which is the solution is basic, but is restricted to a number of these extremal solutions, and number of extremal is combinatorial, dependent on number of variables and number of restrictions, and not at the last of number of criteria. This is practical. I don't know in a classical algorithm for finding this kind of solution. And the definition is about the best compromission solution. Because I use it in the second stage, the integer kind of solution, I provided next the stage of realization and justification, the plan section algorithm. Because this algorithm of plan section, again, transforms out variable initial domain, yes, and number of extremal points is changing. These are very interesting and complete model. The justification, founding and justification are provided on this relation, and the more important is the relation of the section provided in the finale of this development. The next, I propose the synthesis function algorithm for solving the linear multi-criteria optimization. When I have the task to solve the multi-criteria model in integer, appear the problem: what kind of the solution you have to construct the synthesis function. And my idea is to combinatorial search present all criteria, but each of them to register the value of objective function in R class or in Z class. This is the number of combinatorial situations. How I describe in the next illustration. For construct this combinatorial situation, is necessary for synthesis function algorithm to solve all criteria, each criteria, like is described, to found the optimal solution and the pessimum. The pessimum is a worst solution for each criteria. This is if I have R criteria, it's necessary to solve two R criteria of optimal kind and two R criteria in pessimum. 4 R criteria. But this value is used in construction of synthesis function. Synthesis function is constructed for each combinatorial situation. I speak about the first combinatorial. The F1 is solved in R plus and all of criteria in R plus. And the second, only F1 is an R plus, another and Z plus. And I change the situation, and again using the pessimum, the worst kind of solution. Next, in the stage 2, when I have the set of all solutions and the registration of objective function, I construct for each of these selections the synthesis function of this kind. Because I speak about the synthesis function and using the global utility and maximization algorithm, initially the algorithm is interactive. Based on the decision making, can change the utility benefit of each criteria. And changing the benefit of each criteria applies the above algorithm to construct building another set of efficient algorithms. But how I construct this synthesis function using the utility maximization algorithm? In this, I use the utility proposed from the decision making. What meaning the utility value of each criteria? In various decision situations, decision maker can evidently, maybe in domain 0, 1, the importance of each criteria. This is value of the importance of criteria signaled by the decision maker. And I use this value when I calculate the variable alpha g, beta g, using to construct the utility function. In example, I see how is possible. In the next example. The solution obtained for each situation described is efficient, and the next theorem proves this statement. The proof is constructed built by supposing of the contrary, that an optimal solution for maximizing utility criteria is optimal, is not efficient for each criterion. In this case, supposing there exists another more good solution, you obtain the value because is more good criterion, the first not efficient. This is the situation when the next solution improve at least one criterion strictly. In this case, the value of objective function utility is increasing. This is contradict situation that the previous solution is optimal. This I explain in more to economics the time. And a remark is about to change the utility value. You obtain another synthesis function, sure, and another set of efficient solutions. The final algorithm is another algorithm which can found it one single solution of the best compromise situated closely towards solution optimal for each criterion. And the model constructed is the next. This relation with the UK is the worst value of function, maybe maximum, yes, and the LT is the optimal value, and this is why this coefficient is the coefficient to which related about of a situation of solution of function Ct in the moment. This is why if you consider R criteria, obviously the model is the next to maximum. Why the maximum? Because in this relation is evidently which is the solution of multi-criteria model is closely to each criteria when this relation is maximized. Maximized is 1. Yes? This is why you consider maximum lambda, and again because in the minimum criteria and maximum criteria the relation is changed. I separated in this model for restriction for maximum and minimum criteria, which can be from 1 and R1 and of maximum from 1 plus 1 to R, all of criteria. And I solved one model which I propose for you to solve applying the maximizing the utility function with utility proposed, and is interesting. I want to utility of each criterion optimal to be maximal and to ignore the maximum if you see 0, 0, 0. Yes, and I obtained the solution. For 3 criteria, the number of situation is the next. H situation, I construct the H objective function of maximizing the utility, and obtain is not is evidently which sum of this solution coincides, but I obtain it in result 3 solution different which registration of objective function. And you can observe that the registration is can be compared between this. The first criterion in example is of minimum type, yes, if you see the example minimum, and the next two of maximum, and the registration on value of solution or function 10, 20, 10. 11 is 7 is more good than the first, but the second registration is more worse compared. This is one advantage for decision making, to have for each situation, because if the second criteria is more important, you can to select second criteria of maximum the first solution, which registered 20x. Another. This is but all efficient solution I can't keep construct. And if I compare it with the 5-year method, I obtain one single solution with another registration of objective function, which is also is efficient, because it's not can to be compared with previous. This set of solution is improved. The task remain open to construct the all efficient solution. Thank you very much.
Any questions, please? Like a 10 minutes. What kind of software I use to solve these problems? Or you solve this problem on the pen?
It's very hard. This is why I try to implique students, but no. And I solve it manually, because all of the problem initial is solved to propose to as a result, and to improve and to construct and solve. But my wish is to construct and solve. Yeah. Yes. Thank you very much, Dr. Muhenko, for this question.
Any questions? Oh. Certificate of
Thank you.
Now we have section break, because we have coffee break, lunch break, and section break, because the next Stepan Nikol hardware for the
Sono connected
Sì, vedi quelle carte?
Eravamo massimo.
Vreți conectați calculatorul la aici, da? Sau se copie softul PowerPoint, deci PowerPoint? Dar ce soft?
Da, super.
Nu s-a înregistrat ce se aici. Bine, la Alexandru, care va fi moderatorul ăsta, flexibil. Dar aici ce stare? Tot, da? Simt și eu. Dar este, știi ce crește să vii, nu? Să nu știu. este normal.
Cu micul dejun, da?
Cu mii de jur la 263.
Pentru 2 persoane?
Da,
Păi e foarte bine.
da. Ce să spun, au tradiții 150 de nu, asta
Nu, așa, niște întrebări, niște retorici.
Nu, așa de preparare. Că nu am că cineva se uită în același timp. Și atunci eu nu mai pot să... Să pună pe un drive. Asta, nu, de unde? Pe obicei. Eu aș veni cu o problemă. Fac un drive.
Nu este eu o scriu de acasă.
Da?
Da, dar pe doar eu mi-am pus asta. Păi ceva e incompatibil.
V-ați rugat să mă văd?
Cum?
Încărcați
Nu,
poșta ce noi l-ați deschis, de exemplu.
da, nu e.
Și încarcă pe drive. Și de-aia pur și simplu.
Da, eu fac acum că rețeaua este slabă și...
Vrem. Și de acolo, pur și simplu.
Fac și un pic.
Dar ce și de exemplu.
Ce mai rău, că numai că nu se vadă tot în sine.
Nu, dar corporație.
Are, da, vezi.
Eu cred că sunt.
Dacă... Ei, parțial de circunstanțele nu sunt aceleași, deci dacă sunt...
Hai să vedem, cam așa. Nu mai pot să
Ei, eu ce vreau e să fiu și eu online și așa fac eu, șerez ce am eu.
Știam, dar nu e tot.
Cine a fost? Stanislav.
Unul cretin George.
Aha. Hai să vedem ce este. Dom'le, totdeauna s-a spune că eu n-am așa, eu pedepsim. Da, am încercat să fac ceva mai deosebit, mai înțelept. Nu se poate, adică ăsta e conturile. Nu cred, n-am. În fine, asta e, bine că a fost pauza asta. Nu este. Nu cred.
Atunci conectăm așa.
Dar dacă îmi trimiteți link-ul, nu se poate. Acum se vede? Da, acum da, numai că persoana care era online, nu că așteaptă la ora. Deci e cineva lipsă. Și așteptând la ora. Poate mai vin șanse.
În Montpellier,
Oui.
ne fonctionnait pas.
En fait, non, c'est que c'est fini.
C'est francophone.
Non, en fait, c'est que j'étais sur quoi? Je sais pas faire un spectacle et des polices spéciales, plus des animations. C'est ça que je fais dans la tête. Et de transférer un PowerPoint, ça me change parce qu'il y a des gens. D'habitude, je vois que je suis dans la journée, il n'y a pas de problème. Mais là, comme il y a des questions en vidéo, il fallait absolument que ça le tombe bien.
Moi, je suis l'autre texte.
C'est bien aussi, mais enfin, c'est même mieux, mais sauf que, bon, on a vu la moitié des résultats.
Je vais répéter dans mon sens.
À peu près.
Comme ça, Mark, for second.
Et là, vous venez du Canada. Montréal. Donc, vous êtes déjà venu?
9 fois.
Ouais, vous avez eu une visite. Super.
Je connais Chinon plus que Montréal.
Et vous parlez le roumain un peu?
J'ai appris le roumain de 100 fois. Je ne comprends pas ce que je dis. La première fois, c'était en 2005 que je suis allé en Roumanie.
Oui.
J'ai fait 2 fois en Roumanie, en Moldavie, alors Je connais le processus.
D'accord, d'accord. Vous avez vu un peu
La différence en Moldavie, c'est que tu vois à Chisinau. En Roumanie, on se promène un peu plus. C'est des équipes. Chisinau, c'est trop Chisinau. En Moldavie, ok.
Je m'adore.
Câte 20 minute, da? Nu, la ce fost? 20.
Da, la 12 jumate. Ah oui, pratiquement peu.
Care mai încercat și cu el, domnul
This is, yeah.
Stanislav mai încerc să vă spun
Eu am învățat.
supliment. Eu mi-am scris de asta, adică eu mi-am scris cu.
Și ai făcut un nou.
Nu, de dacă mi-am făcut. Eu mi-am mai scris. Și acolo am făcut în
Tu până tu poți spune cine.
dar e clar, nici asta nu are mai clar. Am făcut un bol și am luat un video care am prezentat aici și eu știu eu ce am făcut. Eu mă gândeam că dacă nu ajung utilizez mi-a dus nici nu văd. Nu, nici și nu scrie, așa o să fie nici nu voi scrie.
Ce nu acasă? Eu vreau să ne
Păi așa și eu mi-am zis că dau cu toate și vedeam cum îi conveni în serviciul mare. Eu ca aceea am dat o
Il travaille sur les entreprises séminaires, c'est pas des gens cuisine dans le projet, ça demande du travail. Ça fait partie
ce nu știe. Eu vedeam cu care am stic. Eu ca care lucram și zic. Și veni pe școală. Mă duc acasă. Vreau să vă zic. Trebuie să fii foarte atent. Ce să spun așa? Pentru că vine cineva și că pentru care am întâlnit național. Trebuie să suntem cu chestia asta.
Nu că deja mai zic. Descurajat că iar trebuie să o iei la început.
Așa am făcut eu, vă rog. Eu nu știam unde și ce am calificat. Era varianta de disc, dar am trimis noaptea sau și de fapt și așa. În principiu, care dreptate, tot ce se dare, tot ce nu e buzunar, are context ca să dacă nu puteau, sau dacă eu am singur, acolo undeva la 2 iulie, psihologic, conceptul de a fi psihologic se vede că nu e.
Așa că erau companii, erau proiect care voi țineți mai tine. Păi întreb, acum nu, păi dar de la început, așa zice. Nu, eu. Da,
Ore 4 și ore, dar eu fac. poi era la era fuori. Era molto fuori. Erano 5-10 anni. Facevi il salari. Sono molto sottili, non riuscire a spiegare sono così a credere, come la possibilità di essere dice, come si può mai mult simț decât gândesc, da. Gândirea se dă pe adentru. Trăirea de vecinărie, de ce nu vă va mai toate lumea care am avut o discuție în acest context. Nu folosiți. Nu folosiți elemente de inteligență tradiția. Folosesc fraze care n-au niciun text. Înainte vorbeam că folosesc algoritmul, acum nu am folosesc inteligența. Și asta e același algoritm. Când faci calculatul, el ce face? El vede din el să are posibilitatea de 10.000 de variante poate folosi la corupție. Să aleagă careva și care va parcurge. Ce construiești dragostea? X egal cu 1. Asta e trebuie X1 egal cu 0. Nu, X egal cu X2. Trebuie X2 egal cu 0. Nu, dar vom de dată cu identificata, educata asta în tăiesă, aici nu poate fi, aici nu poate fi, aici nu poate fi. Și atât, el își fac parcurs, acum. Nu trebuie să fac
Faci 10 ore omului și îți dai chestia asta.
Asta cu asta demonstrat că testarea trebuie să aibă o nu prin interacțiune.
Сколько я не бакс, и вот это что фач. И сейчас как следующий. Сейчас любите, мне кажется, это как вот это вот как я у тебя кумир. Дома нет. Но поэтому найти ее делает она медный и
Dai probleme negative și...
Я вчера уже 2000 не прознал, что оно как
Nu prin noi digitalizare, așa. Dar dragi oameni, digitalizarea, не cereau niște documente care erau aprobate de minister, dar le cereau de la universitate. Ce spune? De minister sau de la universitate. De ce mă întreb?
Așa că mă fac viață de viață.
Și spunea că nu chestia asta. Ca o unde undeva era Что ты ему как маленький? А вот я цену стоишь.
Non voglio la caranta.
Dear friends, we continue our scientific reports, and I prepared speech, Mr. Aponia Mircea, and we all. He is very good. What would say? Please.
Thank you very much. În primul rând, mulțumesc foarte mult. E onoare și o mare plăcere de tine să fiu aici, în Chișinău. Mulțumesc domnul Berjan pentru invitație. I will speak in English. Yeah, sorry for the very long list of authors. I know it's unusual in mathematics. I'm not a mathematician. I'm a quantitative biologist, I would say. But still very interested into mathematical biology, mathematical epidemiology in particular. In those fields, it's quite common to have a long list of authors and to credit them in the talk's authorship. So, my talk is non-Markovian real-time modeling of an emerging infectious disease. So mainly it will be based on our experience in Montpellier and Nîmes, two cities in southern France, where I do my research. We were one of the 4 teams in France to try to forecast the SARS-CoV-2 COVID-19 epidemic in France. I'll start with some disclaimer. I have no conflict of interest, especially related to pharmaceutical companies. This is usually the case. You have to do this in France to say that you are not paid by industry. And I'm acknowledging all my colleagues. So in both phases, the major contributors to this set of work. So in fact, it's not one paper; it's like 20 papers I present, less technical than the other talks of this great congress. But I hope we have material to discuss, because there are relationships with optimization problems, PDEs, and so on, and numerical implementation as well, obviously. So the outline of the talk is the following. Some introduction to remind you of the situation in 2020, what was at stake at that time. Thank you, Dr. Puja. And the main results, the methodology, which is the backbone of the work we developed in spring 2020, and then all the results that were derived from that backbone and further extensions. So, in the title of the talk, I was saying that we are talking about emerging infectious diseases. By definition of the World Health Organization, some new pathogen is emerging when it's a new agent, so newly identified, or if it's re-emerging, it's spreading to a new area, or it's generating an outbreak, a large increase. So the time derivative of the number of new people infected increases very rapidly. So that means that we are facing a new threat, and because of this novelty, we face uncertainties with less data, less previous literature, and one of the two kinds of uncertainties are population-wise, quantitative, and these are related with epidemiology and public health. So the question is, we are here, this is a nice fancy diagram. It was updated forward, but here is the screenshot on March 11, 2020, the very day the World Health Organization declared the state of pandemic worldwide. And so, as you can see, there were less than 5,000 deaths of COVID-19 reported worldwide. And the problem is, where will this epidemic go compared to the previous one? AIDS, HIV, or Spanish flu? Spanish flu is considered to have caused 50 million deaths in 1 year, 1980, 1990, more than the World War I, just before. The problem is, what can we do? Because it's a transmissible disease, we are facing the delay you allow to take decisions is translated almost exponentially in terms of health burden, death, and so on. Because you increase exponentially, it's a transmissible, it's a geometric progression. So the more you wait, the higher the cost, but not linearly, but exponentially, before you take a decision. But if you take a too strong decision, then people will protest, because you have very high costs economically, psychosocially, societally, etc. And at the same time, you know that as time passes by, you see previous epidemics in the 20th century. Now, when there is a new pathogen, it becomes a pandemic in 4 weeks. If you take the Hong Kong pandemic flu in 68, 69, it took more than 1 year to reach 50 countries. Well, for SARS-CoV-2 in 2020, it took only 100 days to reach all the countries in the world. Okay, so it's completely different in terms of kinetics. So, for the first time, I would say, since with this pandemic, mathematics were in a situation where forecasting was to be in real time, not in the longer time. So there is a very challenging here, where the research has to be carried at the same time as the data are produced. You see, so everything is shrink temporarily. So the situation in March 2020 was that one, with lots of uncertainty, and the questions were, when will the hospital fee be reached? How high will it be? So we have to develop tailor-made methodological development to quantify, and I insist on that, in real time, the spread of the virus. When can we lift the lockdown, and how to control the epidemic afterwards? For that, we have to estimate the attack rate, that is the proportion of people infected by the first wave, and explore alternative countermeasures, monitoring viral evolution as well, because then we knew as biologists that there will be variants that will have different parameters and generate other test situations, and as well to acculturate the decision makers about mathematical models, because they are not used to take decisions in real time based on models. Usually they just take qualitative counseling from people that said to be expert, but in fact they are not really doing any modeling at all. So, how are we doing this? First of all, I have to insist on the fact that, so the idea is to reconstruct the epidemic and then forecast it, because you can forecast something based on what you see, but then you face the fact when you are in a situation of emergence, because you don't have past history, those phenomenological / statistical approach, now it's called machine learning, this is a fancier way, are not really great because you don't have that history, you don't have data to forecast. So you have to model what's really going on, happening in the general population, what you cannot see for the moment because there were not enough testing, and then you give back in the model to forecast it. So the problem is that at the beginning we only have hospital data, that means critical care admission, and that the most severe cases, what was going on in the general population was unseen. And you have to take, for doing some mathematical modeling, some assumptions. The fact that, for example, you have stationary sampling probability. Each day, the probability of seeing a case is the same per case, okay? So this is sampling probability stationarity condition. We don't have a very local and recent estimate of key parameters, so that means we have troubles if we have very complex models with a lot of non-stationary parameters. At the same time, we have an increasing number of competing processes. People starting to change their behavior because they are afraid of being infected. There are identifiability problems as well. If you start having a lot of parameters, but they are product or ratios, and then you cannot estimate them because they are linked either multiplicatively or additively. And you want to be robust for the next weeks and months. So basically, the game is the following: you have hospital data, and you want to know what is the prevalence, that is the proportion of people that are infected at some point. Pi is for prevalence here. So this is called retrocalculation in the community, being outside of the hospital. But as well to calculate this, so this is the reproduction number. Maybe you know it's or not as well, but here in time reproduction number. S is the number of people not infected yet. So this delta S is the number of people that are the changing number of people within 2 days, okay, 2 consecutive days. And this is the convolution product in discrete time. And what the data here is the probability mass function of the generation time. Is the contribution of each day passed since the beginning of the infection to the overall contagiousness of people. Okay? So this is a convolution product. If you assume that locally you have a geometric increase in the people infected, then you can cancel out those two, and you find an equation that is called the Euler-Lotka equation that comes from the first work of Leonhard Euler in 1760, and then it was generalized by James Lotka in 1911. Well, once you have that, you can forecast the hospital, what's going on afterwards, because you say fraction of people infected become hospitalized. Okay. And as for the trade-offs of modeling, of course you can overfit, you have those data, and it will fit very well by definition by construction. But if you want to be good for the future, you should allow to be less well fitted in the past. And so there is here a trade-off, and this is where the modeling expertise lies. Okay, maybe you are familiar with the simplest form of mathematical epidemiological model, which is called the susceptible infected recovered model. In the ODE ordinary differential equation form, this is the following, and the reproduction number basic at the beginning of the epidemic is simply take the Jacobian matrix and look at the eigenvalue, and then the condition is to have this or not. It is the beta, which is the transmission rate, times S0, the initial condition of the people not infected at the beginning, divided by gamma, 1 over gamma in this setting, which is Markovian, as I said, in terms of memory, because you have, if you take, let's say, you don't allow people to enter anymore, you have fixed number of people here, and you solve this, then you will have an exponential decrease here. And so if you normalize by people at the beginning, the stuff, then you can see this as an exponential decrease. So this is the memoryless process. Of course, you can then the most generic view is what kind of data do you have in hospital, etc., and then you add compartments, people, etc. Well, in the case of COVID-19, that was the timeline. So you have contamination, you start to be positive on tests, you have symptoms that appears if you have symptoms, and you either recover or die. And you have average day, but in fact it's distributed. Incubation is between contamination and symptom onset. Latency is between contamination and starting to be contagious. Well, so you add compartments, but those are not really, this is the naive approach. In fact, if you want to address the fact that you want to relate to hospital data, the only data you have, then you have to separate the non-critical, those people that are fine, they are even not tested, and they don't have, they are not seen by the surveillance system. And those that go to the hospital, they will either die because they are too ill, or they will go to the intensive care units. Maybe they will die there, or they will recover. This in the ODE case, the Markovian case, as I say. Well, they don't really fit the data. Even if this is the first wave in France on the national level, even when we were there, we started seeing that we cannot fit both the admissions and the deaths. And this is because we are assuming exponentially distributed waiting times. But the reality is not that one. People are contagious not from the beginning, but after 5 days. The peak is after 5 days, and they do not go to the hospital with a constant probability in time. So there is non-Markovianity here, as we could say, there is some memory. This is the most important thing. If I take the model I showed before with ODE, and I say that the initial conditions are 10,000 infections at equals 0. A fraction of them will go to the hospital, and that's what the hospital would see if this assumption were true, this on the exponential case. Well, from early data from China, we knew that it was more like this. So, for example, Y-root, but you can take a log normal or the gamma distribution as well, and you see that the distribution is more fixed. So even if you have 10,000 people infected at equals 0, you wait until you see a peak, and the peak is higher than the person. So completely different. If you are if your aim is to forecast, to help the hospitals on the short term, you have to account for this. So we introduced a new way of modeling, which is this one on the generic way. So U and V are vectors that captures any kind of distribution. It can be empirical distribution that is unusual. It might be something else than discretized Weibull, discretized log normal or anything. You go from compartment X to compartment Y with this kind of condition. So this is the scalar product of U with X, and X captures the time you have passed in X, or the residence time, and this is just shifting within the I compartment. So you go into the next day unless you are going outside from Y. So this is the most generic way. I will show you exactly. Then the most complexified model would be the following: if we add vaccination, if we add variants. So those are the distribution we used and fitted. Okay, and the key equation is here, which is the force of infection with respect to a susceptible from H-class I, because we have to consider the fact that people have not the same probability of going to the hospital, because it depends essentially on age and other factors as well. So usually we call lambda I the probability of being infected if I'm from H-class I. So you stratify, you partition the population in an arbitrary number of groups, and the index is I. Because we are in discrete time, this is not just a product. I have to make an upper boundary to 1, because it's a probability. It's the probability to be infected on day T. Okay? But if you take the Taylor expansion, it's just this term that appears. So don't really bother with the inverse here, and the +1 at the beginning. Essentially, this is the term. It's almost linear. And what do you have? The value reproduction number you have to fit. If you start having variants, then we are using data from the medical biology laboratories that provide us I will show you how we calculate this Q. So just a shifting term if you are accounting for variants. Then contact ratios. It depends on lockdown, social distancing, mask wearing. We are taking these information as well from either internal or external data sets. The generation time, I told you, the generation time is this one. So you have a peak at 5 days. And then you have vaccination peak. Okay. So, yeah, this is the force of infection, the lambda I. You recover the continuous time ODE for small values, and usually you are staying in this area. This is not happening in reality. And you add several equations on top of that for vaccination. I don't know if okay. So what are the findings? First of all, we have shown, so these are estimates at several time points. So 1st of April, 15th of April, 1st of May. So the lockdown in France was from 17th of March to May 11th. We estimated the start of the first wave with confidence interval between the 12th and the 28th of January. The reproduction number between 2.6 and 3.4, 95% confidence interval. Less than 5% of the French population was infected by the first wave. As you can see, within the data available with the hospitals in France from the first week of April, we had a good forecast. Those are out of sample data points. We were quite good in the tendencies. You see, even if we were before the peak of hospital occupation. Once we have fitted the model, we can perform counterfactual lockdowns. What would have happened if we had a lockdown 1 week before, 1 week after. For example, we have shown that if the president had delayed the lockdown by 1 week, we would have had 45,000 additional deaths. Okay, we have several other interesting explorations. For example, that age differential control, if we only lock down the most vulnerable part of the population, it would have only marginal effect, because at the end the virus touches all the age classes. The model was good, and it was applied because I had colleagues in Ireland. They used this model to forecast and analyze the situation in the island of Ireland. And they used it to estimate the effect of each measure. You see the bunch of measures here by the government of the Republic of Ireland and the Northern Ireland. And as well, what would have happened if people had masks at the beginning. Now, let's talk about variants. So, when you have a new variant, a new strain of a virus, the challenge is to know by how much it is more transmissible than the previous one. And everything is captured by this formula, which is an extension of the Euler-Lotka equation in the most generic sense. So if I say, so the hat is for estimate here, so eta is the transmissibility advantage of an emerging variant. So you take the current effective reproduction number, the one that is due to the spread of the ancestral strain, and then you have this integral. The integral is just the convolution product, but because the support is positive, you can cut it on the R plus. You have the generation time distribution. It was called zeta, but because we are in continuous time, I call it G. And you have this exponent that is due to the approximation. If most of the mass probability of G is on a short time scale, then you can approximate the change in the dynamics by an exponential distribution. And then you have the age variable, okay, for which you integrate. And then you have two interesting things. Here's the exponential rate of increase of the epidemic, and here is the varying frequency among new infections. If you have a surveillance system where every positive sample is checked for which variant it is, then you have the relative frequency of variants of 2 times, and if the new variant is increasing compared to the other, then it's a very common result from population genetics. This is the selection coefficient. It is the slope of the logit of that relative frequency. The logit being log of p over 1 minus p. And so we have the potential to estimate for the first time in France the transmissibility advantage of the Delta variant that was coming from Asia. And we did the same for Omicron, and at that time in spring 2022, the last measures were lifted in France, and we forecasted that nothing was going to happen worrying. We used the model also to try to estimate the effectiveness of vaccination in real life, and we estimated that between 8 and 14 deaths were prevented per 10,000 vaccinations during the first 9-month campaign of vaccination in France. We performed critical retrospective analysis of the projection and forecast at the national level, both at the national level and the regional and departmental level. So we have developed applications that were online, free of access and so on, COVID Team FR and COVID-DC, and we compared our forecast with machine learning techniques like autoregression with the lasso penalization, exponential smoothing with ARIMA and naive as well. And I don't have time to go into the details, but what we can see is that if we are going 4 weeks ahead, then the mechanistical mathematical model performs better than the others in the general sense. I mean, it's more robust compared to the other. What we have done also is adding stochasticity. Because that was deterministic, if you add stochasticity, then you say that the people are transmitted with a randomly drawn number taken into either Poisson or negative binomial distribution. And we have shown that to suppress completely the virus from France, we would have to wait until mid-August for the lockdown. But more importantly, we worked with computer scientists that coded into Fortran the whole France using the OpenStreetMap database. So each building of France was in the simulation. Each people in France was simulated agent-based with stochastic movements every day. And they got infected randomly in the workplace or in leisure place or at home, and they go into the closest hospital. So this is a map of Paris during the simulation, and I show you the simulation right now. So on the left-hand side you have the mobility and transmission, the transmission chain, and on the right-hand side you have the proportion of people infected at that time. And here you have the wave. So in this simulation, there was no lockdown. It was just the simplest way. So you have 67 million agents that are simulated each day, moving around stochastically. And what's interesting is then to compare the performance of mathematical models that do not assume space or only implicitly with this. And the thing is, if you take the McKendrick-Kermack approximation from 1927, you find that you would expect this attack rate, so this is the midfield, while you obtain all the ranges possible. So that means that the problem to forecast epidemics now, if we really want to help decision makers, is to try to understand what's happening in the rural zones, not in the cities, because in the cities, these are the biggest cities. The biggest cities fall well into the midfield assumption. But if you are going to more rural spaces, then it's not the same anymore. So now, in the last slide, you can obviously go into the PDE framework. It's quite easy because you add. I won't talk about the initial conditions, but the boundary conditions are better because in the boundary conditions you have everything related to the infection, and in the infections you can integrate anything related to those non-Markovian, non-exponential distributed waiting times. So with those Dirichlet conditions, you can capture the non-Markovanity, and this is also the case here, the force of infection, the lambda quantity, and basically once you implement with finite element method the numerical simulations of the PDE, adding the age stratification I told you about, plus those parameters informed by the National Public Health Agency in France, the contact between people of that age with contact of people of that age, this is called the contact matrix, and then we perform sensitivity analysis by computing these Sobold indices. Sobold indices is the fraction of the variance that is explained by the change of parameter value. And for example here, what we see is that most of the variance is explained by what's happening in age classes between 0 and 19 years old. That means that what's happening in schools and high schools is key to forecast the epidemic. And I will finish with this citation from Claude Bernard, which is considered the founder of experimental medicine in France, that said that it's only by the means of application of mathematics in biological phenomena that science will eventually take shape. Thank you very much.
Thank you very much. And any questions, please?
Thank you for the very interesting report. But I wanted one question to you about if do you have any study forecast for the prospect of the prospect?
You mean right now? No, I understand. I don't understand. Forecast, prospective forecast.
To come back this any virus or and if you have in prognosticating to your part about the evolution.
You mean
dynamic.
for SARS-CoV-2 from today to
Yes.
future or in the past?
Yes. If it will come back this another worst.
Oh, okay.
Yes.
So currently there is a new variant of the virus that is worrying and the cases increased in China and it's increasing in Europe as well right now. For the moment it's not too worrying. We don't really know by how much the new vaccine that will be provided in the fall will be effective or not against it, only marginally. But on top of that, there are all the situations that are worrying. For example, arboviruses, the ones that are given by mosquitoes, West Nile viruses in Eastern Europe. But for example, right now in France, there are chikungunya cases, which is a tropical disease. And yes, we think that every 10 years there will be an epidemic, maybe not that strong as what we had, but yeah, there are 30 new viruses that infect humans that are discovered every year. And the ones that have pandemic potential are very minority, but the conditions to make them pandemic are increasing. The fact that we are in big cities, we are more and more numerous, we are traveling a lot with planes. This, obviously, with crowded places and so on, facilitates their dissemination. So yes, we are quite worried about new pandemics.
Yes, I understand.
But forecasting with mathematics is not possible for the moment. What we can do is only developing the method. This is my research project currently, to develop the methods that are ready there. Once you have the first data, you can say how bad it will be, and we have to take early measures. As I said, the key is that it's exponential at the beginning. So you have to take the decisions very early. If you wait, then everything will be damaged, and you have to take very strong restrictions.
Yes, stochastic is the best, but dynamical programming is not the same.
Any questions? No questions? It is your certificate.
Oh, thank you very much.
And now, thank you very much for all. And it's lunch break. See you later here. Thank you very much.
se lucrează la mai multe nivele, de la accesul la date,
Cine a fost ăsta? Mie care a spus, eu nu mă încăl în politicieni, să vină matematicieni.
Sunt în Germania.
Dar el și papa, dar și deci,
Eu, mai
1760. După aia a venit Ida și Ronald Roosevelt în 1917 și modelul cel mai citat este Herman și McKinley cu 1927.
care publică automat, dacă ai corect sau și
Ce mai este
și vreau eu.
Aveți de viață, nu?
Și vreau.
numai equations se violează în care Herman
Și nu a acceptat rolul.
Deci după aia PDI, dar mai recent. Da. De fapt, nu este integrul.
Deci cât e de complicat? Cum ai schimbat calculatorul? Cum e ce telefonul unde?
Până în 1980 s-a făcut fără integrări diferențiate. Mai puțin spun că se vine cu
da.
Așa. Da, aici, că auzi telefon, că l-au citit și n-a. Stai un pic, înseamnă că ne...
Poate fi ceva, poate fi cam șpas.
Da. N-am vorbit eu. Nu văd nimic.
Et sinon, je le prends. Ça convient.
Oh, Lucia, dracu, dar nu spun de sisteme, securitate.